So second day of integration, we're talking about the fundamental theorem of calculus. Okay, this really just means that when you decide to integrate with bounds, you're finding the antiderivative and then you're plugging your bounds in. Remember, you plug the upper bound in and then you plug the lower bound in. Now, this theorem kind of has, sometimes people call it the second fundamental theorem, some people call it the corollary, some people call it other various forms. But this right here, you're integrating a derivative. So notice that you're not integrating or deriving, you're just plugging in the bounds and subtracting. This would be like if I gave you the rate of change, like your soup is cooling at this rate, and I told you to integrate from 0 to 5 minutes, that would give you the total change in temperature over that 10 minutes, okay? And remember the soup and biscuits problem? Yep, for the after party. Okay, what do you call it when you have to add something to an initial condition? Oh, I just gave that away. I'm losing my touch. When you add to an integral, it's kind of like your initial condition there. Okay, average value, this is that f of c. We talked about that yesterday. We did one like that. You'll have a couple more in here. And then I want you to put some stars next to this last one. This is what you really know as the second fundamental theorem of calculus. What this means is when you're taking the derivative of an integral, what happens to those, what are those two things doing to our function? When you're deriving and integrating. What happens when you add and subtract a number? It cancels each other out. That's pretty much what's happening here. The derivative and the integral are like opposite things that they cancel each other out. You do have to deal with the bounds. Okay, so notice what happened here. They plugged in g of x in for t, and then they go times the derivative of g. So it's like you plug in your upper bound and you go times the derivative of the upper bound. So then we got to think, well, what happened to the lower bound? Well, technically there's like a little minus f of a. But let's say a is a number. What's the derivative of the number? What's the derivative of a number, guys?
0.
0. That's why that's off. And on the AP test, that thing right there is always shown as a number. They don't have to do it that way, but that's how all the problems are shown. All right, and so you really don't even have that second piece. Okay, I want you to turn to number 6. This is the first one we're going to do. Okay, so here's the deal. I just put second fundamental theorem on your radar. But when you're working through these problems, how are you going to know that it's second fundamental theorem? Like, there's a derivative and an integral. When you are deriving an integral, I'm going to repeat that over and over again. It's easy to miss, though, when it's like mixed in with all the other problems. So the first thing we do is we keep that sign. All right, you plug in the upper bound. So instead of t cubed, we're going to write x squared cubed times the derivative of the upper bound. This is where most people miss it. They forget to do this. So the derivative of the upper bound would be 2x, because that's x squared. And then, like I was saying before, when you can see that lower bound is a number, which is what's going to always happen, then you could go ahead and write this in, but what are you going to multiply by? 0. So don't waste your time. Okay, when you see that lower bound as a number, don't waste your time with that. All right, now, which answer choice, which letter is the same as that? E. This is not very hard. Like, once you know what to do, you're like actually doing it is not really that bad. These are questions that I know you guys can get. Okay, so let's turn over to number 9, and it's a similar problem, except that they give you the graph instead of an equation. All right, now, I already kind of put it in your mind that we're doing second fundamental theorem, but it's not always obvious. So like on this one, we have this equation, and then we're asked to find g prime of 3. So really what we have to do is g prime of x. So we didn't see the d over dx, but can you still see how we're still deriving an integral? You're taking the derivative of this integral right here. That's second fundamental theorem. So we take the 2x and we plug it in for t, And then what? Times 2, because you got to go times the derivative of the upper bound. Do we need to even write the second part? No, because when that bottom bound is a number, let alone 0, you don't even need it because you go minus something times 0. All right, so now let's find g prime of 3. I haven't even looked at the graph yet. Hopefully we're going to use that here in a minute. So I would plug 3 in. So this is really saying, hey, what's f of 6? And then let's multiply that by 2. So now we got to kind of use what we know about graphs. F prime, f double prime. For f of 6, given the graph of f, okay, are we looking for the y value, the slope, the area, what? How do you know? Yeah, but how do I know I'm not looking for slope right here or something? Because this is f, and this is f, not f prime. If this had said f prime of 6, what's f prime of 6? 0. But what is f of 6? Right. I know I'm kind of like saying a lot about that, but that's an easy mistake for people to make. So -1 times 2, -2. Okay. We're going to do one more free response. This is a short lesson today because I want you guys to have some time. Here we go. So when you see the page that looks like this, go ahead and we're not doing that problem. Actually, we're going to do the problem below it, number 25. Okay, so for 25, you're given 2 different functions, okay, f and g, and it looks like g is a composition function of f. So for f prime of x, you're going to take the derivative. So which theorem are we using? Second fundamental theorem, and how did we know?
Because someone told us.
Okay, because we're taking the derivative of what? Hang with me here. We're taking the derivative of an integral. We're deriving an integral. Those two things kind of cancel each other out a little bit. It's not exactly like canceling. So I want you guys to do this one on your own. Okay, and then I want you to try g prime of x, although we'll go over both of these. So just try. Okay, I want to go ahead and go over f prime. If you still haven't gotten f prime, that's because you don't understand, because it really is kind of like a one-step deal. So what did you plug 3x in for? T. Did you guys use parentheses?
Yes.
Good. Because if you don't put parentheses there, you got to go ahead and square the 3 and put a 9 instead. Don't even try to simplify that. Have I gotten full credit yet?
No. Not yet.
What do I got to multiply by?
3.
That's really easy to forget. You don't need the minus the second part. You could put that as long as you would put minus blah 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 times 0. All right, now in order to do the second one, we could do a chain rule, but here's what I'm going to do instead. I'm going to actually figure out what this thing should be. Okay, what is sine x replacing? Is it replacing the x or the t in this function?
T.
Look at what sine x is replacing.
Oh, the X.
Like it's f of x in the beginning, and then it's f sine of x. So sine x is replacing the x. I like that y'all said t, only because I wanted to point out that's an easy mistake to make. Okay, you got to be careful when you're like, which variable does it go in for? There's something in here, this right here, that tells you, hey, this is replacing the x. So the only thing that changes is instead of 3x, it's 3 sine x. All right, now this problem is very similar to what we just did. Go ahead and, if you didn't write down the answer yet, go ahead and write it down. Okay, so hopefully you got this so far. And then what are you multiplying by at the end? Times 3 cosine x. Okay, you do not have to do part C. You can if you want to. It's not something you're not able to do, but this packet has a lot of problems, so I'm just kind of cutting that one out. And go back to, I'm going to leave this on the video so if anybody's watching, they can know. Go back to number 11. It says on here, omit for AB, but like, why don't you just put a big X through this so that you really know? Because I don't want you doing this and being like, I do not know how to do that. That's fine. You have